Welcome back to lesson 6, where we are going to discuss Le Chatelier's principle and the addition of a catalyst. So the effect of a catalyst is to speed up the reaction without influencing the position of the equilibrium. So there's no change in concentration. It only speeds up both the forward and the reverse reactions by the same amount. Very important to remember this. So the first example, we're going to look at the HaberBosch process. And we know the reaction by now. 3 moles of hydrogen, 1 mole of nitrogen makes 2 moles of ammonia. Now the catalyst that they use is either iron or iron oxide. So the effect on the rate of the reaction when you add a catalyst, you will see after our initial equilibrium situation, the catalyst will speed up both the forward and the reverse reaction by the same amount to establish a new equilibrium at a higher rate. What will the effect on the concentration of the reagents be? So this is the concentration of the reagents graph, and you can see here that after adding a catalyst at this point in time, there is no change in the concentration of the hydrogen, no change in the concentration of the ammonia, and no change in the concentration of the nitrogen, because both forward and reverse reactions are affected or increased by the same rate. Next, we are going to look at the Ostwald process. Now, in the Ostwald process, there are 3 reversible reactions. Now, it is used to make ammonia. So the end product, the end product is nitric acid, where they start off with ammonia, the oxidation of ammonia. This reaction is a very slow reaction. So the catalyst they use here is either platinum or rhodium, or an alloy of the two. Where the second step, where nitrogen monoxide is oxidized again, there is no catalyst used there. And third step, no catalyst used. I want to read what they said here on page 181 of your textbook with the Ostwald process. They say, without a catalyst, ammonia would burn to form nitrogen in the oxygen, and the platinum catalyst promotes the formation of nitrogen monoxide at the expense of nitrogen. In the second step, to promote the forward reaction, the nitrogen monoxide gas is cooled before it is allowed to react with the oxygen. So that is in the second step. The contact process is also mentioned on page 181. There is one reversible step in the contact process. It's the oxidation of sulfur dioxide to form sulfur trioxide. The catalyst that is used here is vanadium pentoxide. So we know that the catalyst will speed up both forward and reverse reactions by the same amount without affecting the equilibrium concentrations.